The Dublin Tech Summit. It has been a hectic morning already, to say the least. It's 10 o'clock. We were hoping to get here at 9. We're all back an hour later, but it's actually a great complaint because the queue is packed outside. The lads have done a great job. And this morning with me, I have Alan Browne of Soarvo. Soarvo. Okay, so there's my first mistake of the day. I suppose the first and most obvious question is, explain who you are and what is Soarvo.
So, I've been working around the construction, infrastructure, and kind of geospatial world for the last 35 years nearly, and I've had my own business for the last 30 years, and in that time, I've seen a huge evolution in what geospatial data is, and really what that is just it's any point on or near the surface of the earth, and it's some kind of attribute. And I think if you take the example of, a lamppost. Sure. A lamppost is in a place, but it has some attributes as, what color is it? Is it rusting? Okay. Is the light working in it? All those kind of things. So that's the kind of things with attributes. And over the last 30 years, but particularly the last 10 years, the ability to collect all that data has changed hugely. Sure. Everybody who has a phone is now collecting geospatial data. Mass amounts. You take an image on your phone, that's geotagged. It has the data. So all of that stuff you have. So everybody is now collecting geospatial. Yeah, it's like kind of like
Google Lens.
Absolutely. And we're using Google Maps, and we're using things. That's all geospatial data, and the proliferation of drones now. So anybody can throw a drone up in the air, and whilst most people, if you have a drone, for a few €100, it's amazing the imagery that you can get and whatever. But one of the things that a lot of people don't realize is that, and even with these low-cost drones, if you fly a particular pattern with that, so if you fly up and down, up and down, up and down, and you're crossing over maybe 60%, and then you fly in the opposite way, you can actually create a 3D model from that imagery, and every pixel becomes a 3D point.
Fuck.
So, so a great example of how that can be used and how it is used now is that traditionally a stockpile in a quarry, so they've a huge big pile. So 50 years ago, how that got measured, they had a fellow with a measuring wheel, and he'd walk around the base of it, and he'd get the circumference.
I've seen those guys. It's like the kids' toy when you were going out and measuring the playground.
Exactly, and then they'd measure up. They'd measure up maybe 5 meters and then walk around again. Measure up 5 meters and walk around again, and they were measuring, and that was how they tried to.
It's kind of like trying to get like a cubic space.
Exactly, and try to. So they were getting the circumference at each point, and then volume. Exactly. So then over time, instruments started coming in, like a total station, which was an optical thing, and a guy could climb up on that with a pole, and somebody would sight onto him and measure points. And then GPS came in, and a guy just on his own could go around, and that was a huge advance. Yeah. But still, a guy had to climb up onto that, and you had the
health and safety concerns and stuff.
But now you fly that with a drone, so you don't need to have anybody there. So that's one example of what geospatial data is doing, sure. And you can calculate volumes, and that's all very easy. And then you can do historic changes. You can, because it's so easy to fly it. You can fly it every week. Yeah, you can see all your changes.
You can get a nice progress map of a project being done or anything like that.
Exactly. But all that data type of data is everywhere now. Yeah. And so in my other business, Correc, we supply equipment for measuring and mapping, and so
it's like basically next logical step is the digital version.
Exactly. So the things the type of instruments that you have is you've got laser scanners. So these are sending out laser beams and measuring that, and you can create 3D models from them. You've got GPS. You've got just updating imagery, like really high quality imagery that you can use. And then you've got mobile versions of that, like so you can mount it on a vehicle, and you've got IMUs, GPS.
So and you can get proper
really high accuracy. So it's like that particular thing, as I say, it's like a Google Maps vehicle, but on steroids. So you're talking accuracy, down to centimeter level accuracy.
That's really cool.
And relative accuracy, a couple of millimeters. So really useful. So we started getting involved in different types of projects using that and using mobile mapping and solving some particular problems. So a couple of applications that we use. So one was in the UK with national highways, where a lot of the particularly concrete roads, they've quite a lot of concrete roads in there that were built in the 60s. So they're near end of life now. So one of the things is that they're trying to see is how long can they get out of them, and how do they have to do and understanding that, because one of the challenges with concrete is concrete takes a lot longer to deteriorate, but when it starts deteriorating, it goes much faster. So like relative to asphalt might start breaking down a little bit faster.
See, this is fascinating to me. As you might tell, I've never stepped foot on a construction site. My background is in jewelry. Okay. So I'm very much shiny things. So this is like an education piece for me as well. So something like that, you're able to kind of get future mapping.
Exactly. So what we did with them is this vehicle. So it's driving along. It's taking loads of information, laser scan data, around the periphery of the road, but it's taking imagery directly onto the road surface, and it's a slightly oblique image that it's taken, like facing downwards. So we're taking images every 2 meters. And what we do is we process that. We have to turn it into an ortho image. So there's a bit of maths involved in turning that as though you're looking directly down on it. Okay. And then we pull all those images together, and it creates what's called an ortho mosaic. So you basically have one huge big photograph of the road surface. We then pump that into an AI engine that actually knows all the national highways rule sets for so there are different types of deterioration. You got fretting, you've got rutting, these different types of things. And we all just think of the word like pothole or something. There's these different types that they can pick up stresses in the road, and then there's some of them that you can actually start. And this is a whole thing is that we're trying to predict where there's going to be failure. So what we then do is we've got this each one of these areas, we create what's called a shape file, and then we then bring that back into the into our software, and then we're able to send out work orders to the contractors to do that. And one of the challenges, so it's again,
just like better time management.
Well, absolutely. So again,
this is where it needs work. Let's go here.
Yeah, and these guys are all on framework contracts, so they have an agreed rate that they get paid, and But one of the challenges historically, how that. Those defects were found was by a guy with a wheel, again, walking along in the hard shoulder, again, the risk of that. So he's walking along in the hard shoulder.
Cranky mother making a phone call to the council going, the road's fucked.
So and he's measuring. So they have chainage points. So how you measure distance on the road is called chainage. So say there's a chainage point that says 10,000, and he's measured 200 meters along that. He'll go, oh yeah, I see something there in the fast lane. So he goes 10,200. There's some defect in the fast lane. So that is historically had it. So, but now what we have, but also the other challenge is a lot of that work is carried out at nighttime. So these guys would arrive in the pitch dark, and they can't see where he was talking about. So what we actually have,
check this out during we can see the traffic outside here today. You're not exactly getting a fellow with a wheel out on O'Connell Street or Paul's Bridge.
So what we came up with then was, so because we have a mobile app that can, so we sent that data to that's basically a phone, but it's got a very high accuracy GPS antenna. So again, you can get down to centimeter level accuracy with this. But we actually also have this augmented reality on the thing, so they can actually
we've got AR and AI
exactly
B2B construction software. I've never heard of anything like
this. So they can now navigate to that point. It navigates them to it, and then they can actually see it. They
explode it out.
Okay, nice. They carry out their repair.
Yeah.
Validate it all on the same device. Photograph it. And also, if they see anything that that actually wasn't identified as a problem and they determined that they could do it, they can immediately take a photograph and in real time send it back and go, do you want us to actually do this while we're here? They can do it, validate all the work that's been done, and that goes back. So the beauty of that is there's a whole audit trail from the moment that the defect has been identified to being repaired. So there's no disputes over whether it's done, how it's done, what it's done.
When's the work need to be done, this, that, and the other, all the kind of pain points across the...
Exactly. So the thing with that, so National Highways, and they've told us, over a 1 year period, that saved them £17 million. And they reckon it was saving them £5,000 per 20 kilometre stretch in terms of how they had historically done that.
But you map that out over a long period of time. That's an awful lot of infrastructure. It's an awful lot of infrastructure money waste.
Yeah,
essentially, that you're able to claw back.
And this is and this is happening everywhere. And this is part of what I'm talking about. How we're trying to help that. We're only a tiny piece.
Yeah.
We have and we're trying to identify little niche pieces that we can really add value. But one of the other things that we can do there then is so that we went through this program with National Highways that we would drive in those roads every year. So you could actually then start measuring, okay, well, we tried repairing this with this technique. We would try to repair this with another. So you can actually see how they're working out, whether it's working. Okay. They also actually have to determine sometimes if there was too much or too many defects in one area, they wouldn't actually repair the defects. They'd actually just say we have to do the whole, they'd have to do the whole thing.
That's a better use of time, money and resources.
Exactly. Right? Exactly. So that's the type of thing that we're doing. So then the other things, one project we did here is with NBI, Broadband Ireland.
Oh, yes.
So they're doing a fibre rollout.
The Air7, is it?
No, this is actually the fibre to the home. Every home in Ireland is getting fibre. So particularly in the rural areas, where the way they deploy that fibre is they just wrap it around the existing air infrastructure. So, but the challenge with that is, again, in the remote areas, there's a lot of vegetation around that, and they can't actually wrap it when there's the vegetation.
This is funny. There's actually down the road from where I live, there's this pup mast, right? It's attached to Pucko. I have been walking past it for the bones of a decade, and it was only last week I was walking up the road with one of my friends who was like, that mast is attached to nothing. Looked up. It's like, oh yeah, there's the end of a wire just dangling off. How long has that been off? They've obviously upgraded the infrastructure to the FTTH, they don't need that pole, but that pole is basically just sitting there on the side of the country road, and it's obviously because of what's around it, the access, they can't take it down, so it's
they're just there. So one of the challenges NBI had is that they had to go through this whole program of vegetation trimming, and that was but they didn't really. They couldn't quantify how much they were going to require, and they were left totally exposed to, people saying we cut this amount and this is the bill. So they didn't really. So we ended up doing the thing that we drove these roads with that. But this time, it's same vehicle, but this time we were really focusing on the LiDAR. So it's the laser scanners.
Yeah.
So these laser scanners they have a particular type of beam that some of the beams can penetrate the vegetation. So you're able to create a 3D model of the vegetation around the wire, and then we actually
safety concerns
exactly. So we actually then have you've got the wire going through. So we can pick up parts of the wire. So then you're able to interpolate the exact route of the wire. Then we have to extrapolate when the extra weight of the fiber will be on it. Where will it be? It'll sag further.
Sure.
So then you have to work. You have to work that.
People don't think of.
So then they worked out how much vegetation would have to be cut, because you have to have a 1 meter kind of cylinder around that whole thing to clear. So they were able to use that to calculate the thing. So that was. There are things you go, that's geospatial data, and you'd be wondering. But so some of the other things that like interesting things that we've done, just actually with some of the horse race tracks, just measuring the thing to actually be absolutely sure, but also the distances are actually correct, because again, measuring those wheels that they often use,
somebody
go
extra skip
up and down, around, and they like so it's all so it's just using that information, and that information is everywhere. So again, we're using this in around ESP transmission infrastructure, like identifying the towers, again, different.
So we're talking electricity infrastructure, Wi-Fi infrastructure, road network infrastructure,
rail infrastructure.
Basically, if it's needed for national infrastructure, this is what we do.
Yeah. But also then we are dealing with drone guys who are doing surveys of roofs. So again, you can survey a roof without somebody having to go up on the roof, and all the danger of somebody having to go up on the roof. You could actually do that with a drone now. You can put a little drone, get all the image, and then in our environment, it's much quicker, much safer. And again, what we're trying to do, and this is like the pillars that we talk about in the Soarvo product. And like Soarvo, we came from all these different jobs that we've done. We realized we're able to solve these problems, but we just got to make it easier.
Sure.
We've got to make it easier to get all this data into an environment, and to get it into a really good environment that's easy to understand, and then get it into the hands of the people who are the right people. So if you are like inspecting a roof, you have a specialist that actually understands a roof. If you're on a road, you've got road engineers that are so it's getting the data and it really to the people who are the right people, that they can make decisions.
That sounds really logical. So like if I go back to let me go back to day one, day zero. Like what was the thing that made you kind of go, we need to do this?
So when we first started doing this, and again, this was in our Correct business, we were supplying these
physical tools,
these tools, and these scanning machines for the vehicles, like they're $600,000. They're expensive, they are. So we were collecting all this data, but we were struggling how to actually put it in front of the people that matter.
Sure.
We were dealing with the manufacturers who had great software for processing it, and you could see it, but you could only see it in a very discrete way. You couldn't see it in the full context of the thing. So that's where we got to, and then say National Highways kept saying to us, well, if you could do this, this would be great. And then, different people go, if you could do this, and it was understanding those problems of going, can we really add value? But the thing that we had that product that we had that was doing that, we called it the K Portal. The company was called K-Matic that we were creating it. And what we had I always described it that product was really an evolution, and evolution is a great thing, but part of the problem is I say, like, evolution gives you an anteater. Like, it doesn't look great, but it's very effective at a particular job, and like that's what that product was. But what it didn't have was it wasn't built from the start knowing where we were going to go with it. So we didn't have the foundations and stuff in place.
It was just that data.
Exactly. And we didn't have so we said, one, we need to be able to get it that it's really easy to get data into it. And then that we can actually, have the infrastructure in place that we can, because this is huge data. Yeah. We're talking terabytes of data that are things like that. So you've got to be able to spin up servers and this to process it, but you need to shut them down as well, because the cost of actually the thing is. So it's having all that infrastructure in place. It's having all that infrastructure and the architecture of that to be able to make it happen, and to be able to then handle all the different data types. So it was pulling that together. We were going, we need to do that, not have the end user trying to do that.
Yeah.
So it was
because I think, like, most end users, especially like if it's in any walk, like we're lazy.
Well, and
can I get it quickly, easy? If that's going to make my life quicker.
Yeah.
Excellent. Let's go.
Yeah, and it's a little bit like you're too young, probably, like the whole, like this was probably why I didn't like computers so much in the old days. Like, it was all DOS. It was all thing. You had to know the commands. You had to think. It wasn't intuitive. You had to know the stuff. Yeah. Like, we're going, let's make this intuitive.
My first job, the till system was based off F keys.
Oh, right.
This was car from warehouse. The infrastructure was literally blue and green screens, all no mouse. It was predating the invention of the fucking mouse.
Right, okay.
So you had to know all of the command inputs. So very much that kind of idea of, if you know where you're looking for and you know exactly how to find it,
it's quite efficient.
It's quick and easy.
Yeah.
Once I knew where I was going, but this is the thing. If you're looking at guys that are, on the road and they're doing tests, if it's hard for them to source the data that they need on the fly, they're not doing it. They're just going to do their thing, right?
So for the Soarvo product, like, we kind of came up with these kind of 3 key pillars of what we were trying to do. We're trying to aggregate lots of different types of data into one, really coherent thing, and illustrate it in a rich, contextualized 3D environment, so that the person who has to make decisions can make decisions around it. And then the collaboration, and again, that is that we're getting that data into the hands of the right people, and it's not we're sending a link to them to whatever. They have full login credentials, and you can, like, it's a full,
they go find what they need.
Exactly. And they can do whatever they're allowed to do, whether, so if they've got edit functionality, they can go in and edit. Really what we're trying to do is to get this data into the hands of people, that they can make decisions and act on those decisions, so they can actually send a work order to somebody in the field who has the mobile app, and actually they can carry out the work, validate they did the work.
It seems like a big piece of this is like the waste, the money waste side. It's the time stuff. It's the access stuff. There's a lot of different kind of points to this. I think, like, obviously a really big part is like the road network infrastructure, as you said. It's the speed of repairs. It's like, if you can actually make people's time more efficient and save money elsewhere, does that essentially has a knock-on effect that the national infrastructure can improve, because there's more money to put back into
and like, the challenge at this moment is we've never been under more pressure with money. So actually, in terms of our road, our major road infrastructure in Ireland, we're actually pretty lucky in Ireland here, because actually we've got great roads generally. Like, they're
for the most part,
most of them are less than 30 years old, and certainly our motorway infrastructure is really good. The UK, and then if you look at the US, they have huge infrastructure challenges, because their infrastructure is it's at full capacity, and it's end of life.
I love the London system here. Just don't bring your car here. So I get the road.
Well, they do have a pretty good public transport network in terms of being able to move around.
I don't know if we'll ever get there.
It'll be a
challenge. Lewis and Limerick.
So some of the other interesting. So we do quite a bit of work with Formula One, which we're always careful about how we talk about it, but so Formula One actually have one of these scanning devices. So every
I need to sit up, because I'm very much into
so every in the 24 hours before a race, they drive the track with this. I'll show you just a quick scan of it, but they drive the track with this vehicle, and they're creating, they're picking up all the information around. So the things that are of interest are the it's not so much actually the surface, because they've got all that is that's engineered to like the nth degree anyway. But it's actually, where's all the advertising, and if you think about it, where the exact advertisements are at any time and anything. Well, how if you imagine you were playing a Formula One racing game, well, if you were in China, you might see those ads in Chinese rather than in English.
Yes.
So, but that's all geospatial data. That is actually where they are.
I've seen those type of advertising boards before.
Yeah. So then you've got all the things of camera positions, all that is
so they know that this camera feed is going to this.
But it's also how much time is like that particular, like if how much time is stuff in vision if it's in that camera zone. There's an extra bit of value there depending on.
So when they're actually looking for sponsor money,
exactly, there'll be all those different things. So
this is going to be average 6 seconds lap. This is going to.
Now I'm not sure that's exactly.
No, but this is. I understand the idea, the concept. It's like by being able to map out all this stuff.
So if you have
to make better decisions when they're making.
And again, that data is all sitting there, easily visible, and it's just, and the whole thing with this is I've a presentation there. If you've got to keep sending it by Dropbox or whatever, this is all in one place. You could just give the relevant people access to it. You don't have to send it. You're not sending it anywhere. You're giving the relevant people access to it.
This is so fucking simple.
Yeah.
This is very when it comes to construction in this area, I'm very much out of my depth. But I've learned a lot. That makes a lot of sense. It's just here. Yeah. Here's what you need. Now you can go do your job. Yeah. Nobody's asking questions. Nobody's chasing their tail. It's just here is the tools to go do the thing.
Yeah.
It sounds really
and again, that's why we keep going back to that. Aggregate, pulling all the different data types together.
I think this is what people don't understand. Yeah. I think this is when people hear data right now, I think there's this whole Facebook are stealing my data and all this kind of and privacy stuff we obviously need to talk about when it comes to data and stuff like this. But there's different types of data, and what people are hearing about day to day on the internet or on Facebook and Twitter, that's not this is relevant structure.
Yeah, and so another type of thing we do. So we deal with a number of police forces, and so if you think again, this is the beauty of when data collects. So now with crime, major accident scenes, they carry out laser scans of the
really?
The Gardaí do it here, and the UK police force. So they're carrying out laser scans. And they've got some GPS in their things, so they carry out very accurate surveys of the scene. And if you think about it, so you now have a 3D model of exactly what happened, and you actually can see the damage. You can see the damage. But also what it is when that's collected, that's fact.
Yeah.
So if you think of just say in a crime scene, so historically, say there was something on the ground and a guy has measured that with a tape. How can, when you're giving evidence in court, how can you prove that the end of the tape was actually at the wall? Do you know what I'm saying? So someone say, definitely did that. I actually measured it correctly. Where once you've done a 3D scan, that's there forever. You actually can just go into the model and measure what's the because everything is shown in the 3D, and it's funny. So you have
so many uses
full audit trail of the thing. So and it's valid there forever. So you can actually go back later and say, actually, we didn't think about that. Go back and have a look at the thing and see, what was that measurement? What was that? So that's the beauty of it. But because we do that, so you're just talking about data protection. We have to have a huge amount of security around our data. Any of the work we do in the UK, that data is all actually hosted in the UK. Any of our Irish stuff is EU hosted.
Sure.
And then if we go to the States, we'll have to have all that hosted in the US. So, but also we've doing penetration testing. We've all the certification and all our stuff we're using AWS infrastructure. So and that gives us a lot more security than it's funny. And that is the other beauty of what we have. So any of this kind of geospatial data, historically, for each different type of data, you need some kind of processing software. And you need a powerful PC to actually do it. But everything with ours is in the cloud. So you need a good connection. All the power is in the cloud.
You just need internet.
You need an internet connection. A reasonable graphics card, probably just so you can actually show something.
But most high-end phones
exactly
have that.
Yeah, and then you can visualize the data and work with it.
It's so basic. Like, it just seems to me like it's made something that's really complicated really simple.
Yeah, and
I'm sure it's
it is. Well, that is our whole idea, is trying to make it simple and basically to go from data to insights. And actually for people to be able to make decisions.
It's not data for data's sake. It's actually data for a function.
And to give an idea, I was only thinking about it the other day. Part of what it's like is so many people now have dash cams in their car, and they're driving along, and
Oh, don't even get me started on dash cams and doorbells, because I have a few pet peeves with this stuff now.
But quite often now you hear, like, there may have been an accident or something. The Gardaí are asking people, anybody who may have had some like a dash cam or something.
Like I personally have a problem with the ring doorbells. I'm not a fan. Like, I understand them for security purposes, but my thing is they should only record when activated. That kind of way they shouldn't, because if I'm walking past someone's house, like, why are you recording me? Leave me alone.
If you're on a public road,
if I'm walking down the road there and there's a house up the street, it's like, why are you recording me? If the second I walk onto your property, fine. Now we're talking security purposes.
Well, so one of the things, actually, it's interesting, actually, you said but actually it's very relevant. So if you think about it, so when I was saying to you, like, for national highways, when we're actually driving those roads, we're driving them in full traffic conditions. So we have to blur out all the registrations and any faces. We have to blur out anything that's being picked up. That's part of our GDPR stuff. We have to have blurred out anything that is there, because I think, do you remember years ago there was they had, like, from Google Maps or Google they you picked up Bertie Ahern out canvassing.
Yeah. My car still outside. My first car I can still see on Google Maps. The day they changed, I'm going to be very sad, because every once in a while I get to copy my mother's dress, see my first car sitting. So
that's part of the challenge. So the Google Maps stuff, and that is great, and the Google, but like, the thing is the accuracy on it. It doesn't let you get engineering level data from it. But also, it's actually you don't really have any knowledge of how often it's going to be and how up to date it is in terms of the collection. Because these are the things, if you think about, like, if there's been a major accident, and we look out the window there and you can see a yield sign on it. If the driver says there was no yield sign there, you can go, well, actually we can say, well, we collected the data on something, it was definitely there then. And then, so this is the piece of there's so much data all the time now. It's how do we get that data? Because the process, and it's huge. Handling imagery and stuff like that. It's big.
Yeah.
So we're handling like terabytes of data, and it's actually, and this is the big thing, is, so how do we get it that we handle it quickly, but also that it's easily accessible, but it's coherent, that we're bringing all the different types of stuff together that people can make some sense of it.
So, like, what? So I suppose the obvious question is, what's next? Where do we plan on going?
Well, we've really only launched the product in the last few months, and we're seeing real interest from, I suppose, what would be the type of people that we've always dealt with, who are surveying companies, local authorities, the likes of the big national organizations. But what we really see the opportunity with this is that it can go into the hands of a small drone operator, because it's and small businesses that don't need to make big investments in hardware and stuff like that. They don't need to make big investments in hardware and software.
It's about accessibility, basically.
Exactly.
To the technology.
So what we're saying is, the collection of the data has been democratized. Everybody has a phone. The collection has been. We're trying to democratize the handling and processing of that data.
The handing back of the data after the fact.
Exactly.
Sounds so obvious. So, yeah, I mean, that's like an obvious question. I suppose like the last question I have for you is obviously about why we're here today. So we're, as we mentioned at the start, we're in the RDS, we're at the Dublin Tech Summit. You're obviously speaking. What's the talk going to be about? When are we talking?
So we're talking tomorrow. I think it's 3:30. Today, what I'm talking about is how we're trying to use all this data in terms of managing infrastructure. And we're talking about a couple of key buzzwords. So drones, we're using lots of stuff around drone data, and AI. So where we're using AI.
Honestly,
to try and predict.
If you make a buzzword bingo card, you could just do rows of AI and see how many times the word AI is going to get said over the next 24 to 48 hours. Joe, that was actually a game I'd love to play at these events, is a bit of buzzword bingo, because I've always said it, because I go to a lot of the events and AI is obviously the buzzword at the moment. A couple of years ago, everybody was talking NFT. A couple of years before that, it was crypto. Before that, it was IoT. I can literally probably tell you the buzzword of every year for the last fucking decade, which is really sad, but here we are. But no, the word, like the AI is logical. And the reason why I love events like this is because people hear data privacy and they shit their pants. People hear AI and they shit their pants. People hear like these, but like when you actually break it down and you look at what they actually mean and what they can be used for in reality, because I think when you're looking at, like, when people go on YouTube, they're going to get the worst of the worst stories. When they're looking on TikTok, Twitter, Instagram, social media isn't the places where you should be getting this information about what is data privacy, or what is, democratization of data, or what artificial intelligence is, because you're going against the people who fear change, who are going to fearmonger about it. Whereas you come to events like this and you listen to people who actually know what they're talking about, who are experts in their field, and it's like, data's not bad. We process it properly and we're secure and we're safe about it. AI is not bad. It's a tool to help us improve and do things in a better, faster manner. And like, these events are brilliant for that kind of stuff. So like, even from your own, like, I assume like getting to come to these events and actually talk it and sharing what you're doing, that must obviously really help in terms of like making people understand like the focus of the business and what you're trying to achieve.
But it's also seeing what other people are doing with it. Like that's what I love the most, is you just actually get to see what these other people are doing, and they're going, wow, my little world, I understand what we're trying to do, but then we actually look out the door and we say, actually, wow, that's amazing. So
someone completely in a different space.
Absolutely.
But it might even set off a nugget.
Totally. I've never not learned, from somebody. Whatever they're doing, you'll always learn. Maybe it might be not to do it, or whatever.
But these are stories we learn.
Absolutely. So that and what is fantastic, it was amazing to see the crowds queuing up to come in here this morning. So it's
it'll be exciting now to actually get a wander around the floor and actually.
I'm looking forward to
experience the place. But like, I don't think there's any questions I necessarily have left for today, unless there's anything that you think we should talk about that we haven't.
Not that I can think of.
Not that I can think of. I think we've covered an awful lot. Like, in fairness, in 45 minutes, we've covered quite a lot. No, this has been a pleasure. I think there's I obviously, as I said at the start, construction isn't a space that I would actually necessarily say I understand. So I feel like I've learned a lot from this.
Well, the thing is all our lives depend on infrastructure.
Yeah.
As you say, you drove up on the road today. And actually, one of the interesting statistic, now this is a UK statistic from about 10 years ago, but 30% of traffic jams were caused by infrastructure failure.
All right.
So that's the importance of it, and like the cost of traffic jams is unbelievable. Like in previous years, we used to be doing a lot of stuff. We used to supply correction services for the police forces who were carrying out these surveys of a day, and we would provide a lot of the instrumentation for the police forces in the UK. But it was National Highways who paid for the equipment, because it was really important for them that, because the police had a legal responsibility to get all the information, but National Highways wanted the roads opened as quickly as possible.
Yeah.
So the quicker they could get the accurate information, the quicker they could clear the scene and get the traffic moving again. And so,
yes,
National Highways had a imperative. Obviously, they want the roads to be as safe as possible, but they need to be open and moving.
Yeah.
The police had a responsibility to get it. So that was why they wanted them to have the best equipment to be able to actually carry out that.
Exactly. Huh. That makes So much
makes sense.
It
but
makes so much sense.
Yeah. Now, unfortunately, all government spending doesn't always make so much sense.
We know that.
That's
another conversation for another day. Yeah, we're not going to get into government waste because I don't know. Like, I'm from Limerick, and obviously there was the president of UL stood down yesterday after $5.5 million overspend on student accommodation that doesn't exist.
Oh, so, okay.
Yeah, so that was a fun bit of a story.
And lots of overspends on IT implementations.
I'm sure, but those accounts haven't come out yet.
Yeah. So but they, you know, and again, this part of what we're trying to do is by bringing all this data together, it's trying to minimize that.
But I think it makes it more transparent as well, because if that data is going to be in time available, like people who have a bit of, I suppose, mathematical minds behind them will be able to look at this data publicly and kind of go, well, actually, this is what this should actually be. How is it this? And start, you know, figuring out the gaps that are in it. And even then, like, I know a lot of data nerds, people that like would look at it and actually maybe even be able to come up with new solutions going forward. But without the information, you're just basing it off of an eye test, and the eye test that comes down to skill set and experience. So you've got,
and in more and more, this is another thing, and this is why getting all this information into one single place makes a huge difference. If you look in the rail industry, you look in the utility industry, you look at any of those places, their biggest challenge is aging workforce, you've got these people who are getting close to retirement, and they have everything in their head.
Yeah, they just know it.
And they know it. And they're going, how do we get that out of their head and into a place that it makes sense to everybody else?
So, yeah, this is brilliant. I don't know. My head is spinning because I'm just like, I this is why I like actually doing this whole podcast, because I get to talk to people like yourself who actually know stuff in areas that I'm just like, I know the words, but like I can go away saying, I understand this now. So no, that's been really, really good. Thank you so much. If anybody wants to contact you, where would they find yourself, find the company? I suppose give us the.
So give me the Alan Browne. I'm on LinkedIn. Soarvo.com. SOARVO.com.
Yep. Instagram, TikTok,
TikTok.
I like how we have we're getting words out from the producer over on the side. Yeah, no, basically Instagram, TikTok, Facebook, LinkedIn, Alan Browne, Soarvo.com. I suppose if you want to find out more, have a look at the website. You're going to see what you're going to need to see. And then obviously you can contact the guys. They'll have a contact us form on the page. And then from our own perspective, we're obviously live on YouTube. We're going to be on Spotify. We're on all of the social media channels apart from X. We don't talk about that one anymore because, you know, that guy's bad. But wherever else, for Goosed.ie, we are going to be at the RDS for the next 48 hours. We're going to talk to many, many people. So you're going to get used to seeing my face on YouTube over the next 2 days. And on that note, love you, leave you, and thanks again for coming. Brilliant. It's been an absolute pleasure.
Thank you.
We might catch a pint over the next 2
days too.